All right, so in this next example, you're going to do this one for practice. So we'll leave this as an exercise for you. E raised to the k times x, where k is a constant. Now, this is a very frequent function that we have to integrate. So, the way you do this is with substitution rule. So we're integrating an exponential function here. It's not just e to the x, though. So it's not, note, not just the integral of e to the x. There's extra stuff up there in the exponent. There's extra stuff there. So we'd actually have to use substitution rule. So we need to use a u sub. So I want you to practice this one. And what you would do is you'd let u equal that constant k times x. And then when you calculate the differential du, you're going to get k times dx. So derivative of kx is just k, and then we multiply by dx. And, well, might as well just do it. I mean, we're already there. So when we look at it, this k times x, that's going to become our u. And then we look at the leftover things. We have a dx, that's it. And in our differential here, we have dx that's left. But we also have this k, so that k is an extra constant. So what do we do with those extra constants? We move them to the other side. So we normally solve for what we have. We solve, in this case, for dx. And so when we do that, we get dx is equal to 1 over k times du. And so if we start substituting all the terms in, our integral, which was e to the kx dx, that e to the kx is going to become e to the u. And then this dx becomes 1 over k times du. And then we finish integrating. The 1 over k is a constant, so we just put that front. E to the u is, antiderivative of that is just e to the u. And then we have our plus c. And then we convert back to the original variable. So we just substitute in, instead of u, we go back to k times x. So this is going to be 1 over k, e to the k times x plus c. And so that's our antiderivative. Now, these ones, once we kind of get, once we get into the course, and you're going to see these a lot in Calc 2, these are going to be really easy enough, and you'll probably have these memorized, and you probably should have them memorized if you're when you go into Calc 2. So we kind of give these a special name. We call these K-forms. So there's ones for exponential functions like this. So you want to know this one. Integral of e to the kx dx is 1 over k e to the kx plus c. But then there's ones for sine and cosine and some of the other ones as well. So sine and cosine are the more frequent ones. So we also have the integral of sine of kx dx, and that's 1 over k negative 1 over k. Get it right there. Negative 1 over k cosine of kx plus c. And then there's one for cosine as well, cosine of kx. And that's just 1 over k times sine of kx. So these are special enough, and they're more frequent enough where you'll probably have these memorized, and it'll be helpful for Calc 2 to have these memorized. But the way you would do each of these is with u substitution, and it would be the same substitution. Let u equal k times x. All right. So let's keep going. Just keep practicing these. We'll do a few more.